QSO Today Amateur Radio Virtual Expo, which is all we have now, unfortunately, because of coronavirus is giving us all a good expo. And I'm hoping we can have in-person presentations. I've been giving talks all over the place, so it's a bummer not to be able to do that because I like to go and meet people. Okay, so how's about me? This is my official ARRL photograph that I collection in 2018. So I was licensed in 1997 in Trinidad and Tobago, and licensed 2001 in Brooklyn, New York. Yeah, Brooklyn, New York at the King Cloud Repeater Association. Interesting story with that. At that time, I was a new immigrant, and I didn't have all my stuff. And I went there to the exam, and they said, "No, you need a social security number." I'm like, "Well, they didn't send that to me yet." And then they turned me away. So I went to Jim Haney at ARRL, who was the president, and he just basically threw his hands up in the air. Eventually, a month later, the card came in the mail, and I came. Of course, now they do away with all of that. You just have to have FRN. So that's an interesting story. What do I do for a living? I do IT. Big shocker there. I work in the financial industry, and I also do video production at my church. I'm a director of the multimedia ministry there, which is where I exercise my video production chops. And I also run a YouTube channel, which I'll explain at the end. So ham radio has kept me technically curious. This is my main reason for being in ham radio, because I'm a nerd, and has enabled me to learn a lot of tech and engineering. I have two people that are my biggest influences in ham radio. Unfortunately, they're no longer on our bands here on Earth. They are Tony Lemak, 9x4 Alpha Lima, who's a teacher. Cancer took him in, I think it's 2016. And Steve Mendelson, W2ML, cancer also took him. So I'm really thankful to those guys when they were alive, what they taught me. And they said, never settle, always stay curious, my friends. So as you may know, I got involved in ham radio in school. And I'm proud to serve the ham radio community, of course, as director of ARRL, district chair for YLRL. It goes well beyond that, though. I don't just hold office. I go around and I talk to people. I found what's going on. And I also, love to share the tech knowledge. I'm very active on social media. I answer a lot of questions. I don't berate people and tell them, read the manual, you took the exam, you should know this stuff. No, I just tell them, I said, you do it this way and probably pick up a book. Here's a good book to go and read. You usually need a BLRL book. So, all right, enough of that. On radios, I use Flex radios, but you know what? I talk about other radios too, so it's always good to talk about what's there. I mean, everybody has a different cup of tea. And an important disclaimer is nobody's paying me to do this, not even Dan, with his millions of dollars he makes from these seminars. But thank you very much for holding these. I'm kidding, Dan. Dan doesn't make any money off this either. So my main activity in ham radio is DXing. Ever since I was a child, I was an SWL. My dad brought this into my life when I was 4 years old. He taught me shortwave listening. But, more importantly, rather than just enjoying talking, I enjoy radio for radio's sake. I enjoy learning about radio. I enjoy, just the magic of radio. Anybody who learned about radio, I think, and truly appreciates radio thinks of it as magic, right? How you listen to stuff from so far away with nothing, no satellites. Well, if you use satellites, no fiber optics, no phone company, no nothing. And that's important because when those things are not working, we can work. So that's very important. Other things I've done and I still do. I do ARES. I used to be very active in New York City ARES when I was there, including 9/11. And I love homebrew. I love kits. I fly drones. I love flying drones. I'm really into that. That's a cool new hobby I'm picking up. And some of them require ham radio license, believe it or not. So it's always good to have a ham license. Your ever versatile ham license. I love contesting. I love rag shoes. I have a group on 75 meters that I meet up with sometimes. So let's talk about what's a software-defined radio. Well, an SDR, and I promise there'll be some pictures. So the essence of an SDR is that in a radio you have analog components, like you have things like you have a tuning circuit, we used to call it a tank circuit. You have a detector. You ever build a crystal radio? You have the little cat whisker and galena. We've all done it. Or a lot of us have, especially those of us who've been around a while. Or you get a crystal diode. And on the transmitter side, you have a modulator. In the days of AM, it was big hunks of metal, the big modulation transformers. I saw a video by Randy K7AGE about WLW 500 kilowatts. You could believe how massively monstrous that thing was and why all the other stations wanted to shut them down. And they eventually did get them to shut down. They were clear channel worldwide. So the main things about SDRs, and one thing you'll always notice that I didn't mention directly here, but I'm alluding to, is that the main benefits of SDR are on the receiver end, right? And really, the receiver is where the magic happens. You really want a good receiver. But there are some benefits to the transmitter. Like I'll talk about things like what you call adaptive pre-distortion, which is a technology that SDR helps with. So anyway, you have two types of SDRs. You have the direct sampling, which basically grabs all the RF out the air, digitizes it, and converts it into digital bits, does processing in the computer, demodulates using software, and then spits it out as RF into your headphones. Then you have the baseband SDRs. You have some analog components which down convert the RF onto something called a baseband signal, which basically is a very low frequency signal that's kind of in the audio frequency range. And you have what you call IQ signals, which are in phase and quadrature. And those are fed into the left and right channels of the sound card, which I'll explain. That's important because it explains something later on. But they feed into the left and right channels of the sound card. And that will allow you to have an SDR, a lot cheaper. So what is there available today or is going to be available? So you have a lot of these different SDRs. A lot of the conventional radio manufacturers, and you find this way, one of my other interests, by the way, is electric cars. I mean, it's not everybody's cup of tea, but I love them. You'll find that the boutique manufacturers, in this case, this Flex Radio, has been around for a while, and they've been kind of like, the SDR guys on ham radio. And then as the technology matures for ham radio use, the other manufacturers have taken it and mainstreamed it. Like you have ICOM was really the first one to really do that. And then you have Yaesu jumping on the bandwagon. And then you have Elecraft bringing out the K4 with their, that's still in under production. Then I mentioned Apache Labs because Apache Labs, they took an open source design, which was the high performance SDR, high performance software defined radio, and they made a commercial product out of it. Of course, there was some sort of cooperation between them and the team that built HP SDR. So that's a cool piece of tech. The difference between these radios, you'll find that Apache Labs, I'll explain why Apache Labs is different. Apache Labs, they have what you call a thick client SDR. So what happens is they digitize everything and they send a whole lot of data to your computer, and your computer does all the decoding there with the software. Flex takes a different approach. What Flex does is Flex does the same thing. It digitizes all the signals from the, all the radio waves. And then it does its processing inside the radio. Still software, but all of the processing is done inside a radio. And what Flex will do is Flex will send only the information you need. Like, for example, they'll send audio signals, they'll digitally send audio signals to your computer or a Maestro. They will send graphic images of the radio spectrum, the pan adapter tiles. So basically they break up the whole visualization of the radio spectrum into little tiny graphic images, and they send that over the wire, and so on and so forth. Well, ICOM and Yaesu and now Elecraft, they're basically just taking all of that and putting it in the conventional radio form factor. So you can get an ICOM 7600 and a 7610, and they really don't look that much different, but the performance is a lot better, and then you get a lot of the other benefits of SDR too. And that's good, because I remember I was at Hamcom in, might have been 2017 or 2018. Might have been 2018. Well, it was sometime. It might have been 2019, to be honest. And K3LR was given a talk, and he said that, everybody knows who K3LR is. He's Chief Operating Officer of DX Engineering, but he's also a very big contester. And Tim said, he said, hams like knobs, and hams are going to always like knobs. They don't, a lot of people aren't into this point and click stuff. But so you have to build radios with knobs. And that's what these guys are doing. Yaesu now by the way, has the FTDX10. And there are a couple others I've mentioned here, like there's a Russian manufacturer called Expert Electronics. They make one called the Sun SDR. They actually make one called the Sun SDR MB1, and they have the Sun SDR Pro, which is basically the Sun SDR MB1 minus the display and such. So it's just basically a receiver / transceiver module that's controlled by a computer. By the way, Flex did this all-in-one radio thing, just like ICOM and the others with the 6600M and the 6400M. So what they're doing now is they have an all-in-one radio. And initially I was a little skeptical, because I think, the main advantage of Flex is having the computer control radio. But no, if you take this and you want to go somewhere like Field Day, right? Or you go into an EOC or something, you just carry the whole radio. You don't have to carry a computer. And you have, you're easy to set up. All right, what can an SDR offer you? Well, the most obvious benefit and the most visible benefit, to use a pun, is that instead of just hearing the radio signals, you can see them. And when you see them, you generally have a lot better ability to find out what's going on in the radio spectrum around you. The other good benefit is performance. So, and this, generally people think of this as just for DXs and contesters, but performance of an SDR can actually help you with all sorts of radio uses. And when I talk about performance, the key characteristic of performance is basically resistance to nearby interference, to interference from nearby signals. So you're basically operating in a crowded band. Integration, where everything can talk to everything, meaning that your radio can play nice with your computer and other equipment in your shack without serial cables and all sorts of other stuff. And then finally, remote operation. And remote operation has some very good, surprisingly interesting use cases. Let's talk about visibility. So this is a 160 meter, it looks like a contest. And typically you'll find that an SDR will show you, you can see as much or as little as you want. On mine, I can see up to, I think, 14 megahertz of spectrum at a single time, which is kind of useless. But when you think about it, it might actually be good to tell you, so like if you at a glance what propagation's like, you'll see all of the whole spectrum and see where it's active and where it's not. But this here, I'm just looking at the whole band, and I see a lot of CW signals there. And I see above like 1870, things are a little clear. So if I want to play in the contest, I know I could stay down the lower portion. If I want to go up higher, if I want to avoid all that noise, I could go up higher. But more importantly, if I'm operating somewhere, I could see there are some little holes in there. I could go in and operate, where there's little activity. So it gives you a chance to seek out a clear spot on the band. If you operate CW like I do, you can find out, you can decode with CW skimmer. The cool thing about an SDR is that you can feed a wide amount of spectrum into a decoding software. And today we're doing Morse code and digital modes. We're not doing voice yet. Our speech recognition technology is getting good, but I don't think any hams have come upon that yet. And then, of course, you can overlay this data on the PAN adapter. It's quite nice to do that. And you could do point and click DXing. And I do this with my DXing. I have CW skimmer playing in one window. And what I look for, if you see like on the chart here, you'll see like little 599s in the corner there. This is where DX just answered this person. But there are other applications we're going to talk about which are not necessarily DXing. I just thought I'd show you this. So I have to talk about this article. I hate to be that person. Somebody actually complained to me about this article. International Broadcast Station Interference Overwhelms Hurricane WatchNet. I thought it was kind of ridiculous, but because you really can't control the schedules of broadcasters, and you can't control when they come on. They just come on and they just wipe out everything, period, end of story. But with the SDR, you can actually go on and you can scout out a frequency that's good and relatively free from interference, and you can analyze that over time to look for good places to basically set up your nets. I mean, the reality is, you tell people that you want them to stay clear of the frequencies, but reality is that doesn't always work. So sometimes you just have to avoid the trouble. I tell people, you have to be good neighbors on the bands. Yes, you do. You really do. You have to be good neighbors on the bands. But at the same time, my pastor in church was telling me, he said, there's one thing you have to understand. He said, I would say now in a sermon, he said, you cannot change people. So you can't change people. So what do? You avoid the trouble. So long story short, with the SDR's visibility, you can actually go and look through the spectrum and see who, see clear spots. You can do a little bit of homework. Even if you have to switch frequencies mid-net, unfortunately, if like a strong broadcast station decides to start up, and it was unanticipated in the schedule, because a lot of these are basically Iran and North Korea and other countries that are just going to tell us to just go, whatever. You could just go and immediately find a clear frequency. You don't have to spin the dial and look. You can just see. The other cool feature you could have is if somebody is, if you have a persistent interference source on the band, you can do that. You can put something called a tracking notch filter. I have a practical demo of that I'm hoping I could show you. So let's talk about the performance. One of the biggest effects that an SDR has had on the radio landscape is performance is now cheap. So you can get performance with analog. Let me just clarify this. You can get good performance with an analog radio. but it's going to cost you a lot of money because you have to take extensive pains when you're designing a receiver to mitigate the effects of external noise. And then when the signals are passing through the radio, you have the mixers. When you mix two signals together, you have something generated called phase noise, which you have to mitigate. You have to select your components to lower that as much as possible. In a direct sampling SDR, you don't have analog mixers, or you don't have as many of them. You're digitizing as close to the antenna as possible, meaning that you're taking radio signals, you know, with a minimal of analog processing. There's a caveat to that, which I'll explain. And then everything else is just math. So your radio now, your software in the software-defined radio will do everything that the analog components did, but minus all of the interference from the analog environment. So this enables you to have a much better, cleaner signal path, and you don't have as much problems when it comes to like man-made interference or even interference within the radio. So you'll find that the noise floor, you'll have a lot lower noise floor, and the dynamic range. So the concept of dynamic range is the difference between the loudest and the softest signals that you can hear. You know, so this cool story about dynamic range. When I first started DVDs, like, you know, listening to DVDs and then later on working on producing DVDs, sometimes you find that the center dialogue is normal volume, and then all of a sudden an aircraft passes over and it shakes the whole room. So that's the dynamic range of a DVD. And a lot of these AV receivers that people have in their home theater have something called night mode, which basically kind of levels everything and compresses it in so that you could watch a movie at night without waking everybody up. So anyway, the performance that SDRs are designed for are what you call are for crowded band conditions. And next we're going to go to Rob Sherwood, and I'm going to have to open up my browser window for this because this is kind of small. So just bear with me one moment. All right. And I'm going to have to share this. Okay. Hope y'all can see this. Okay. Rob's a cool dude, and Rob, I think, was on, I don't know if Rob was on here one time. So Rob here, he publishes something called these receiver test data charts. What Rob does is Rob would go and he would basically either borrow radios, or he would walk into a ham radio store, I think Ham Radio Outlet, and just buy a radio or get it on loan from them, test it, and then return it to them. So I don't think he buys it. I think he has an arrangement with them where he buys a radio. He borrows a radio, a demo model of the radio, does a test, and then returns it, and then they sell it at a discount. So he has a whole bunch of these radios in a chart here. Let me make it a little bigger. My eyesight's getting old too. So you'll find that the top, he has these radios sorted by the dynamic range, third order dynamic range, narrow spaced. In very simple terms, that means that he sorts them by how well they could do in a crowded band with signals nearby to you. So let's say you're on the band and you have somebody blasting away at, let's be real, 5 kilowatts, because some people do that, okay? Nearby to you, 1.5 kW. But really, somebody's near to you and they're 60 dB over S9, and you're trying to listen to a little flea whisper signal, and this person's barely in the noise. A lot of these older radios with the limited dynamic range, they would then desense the receiver, cut it back. The AGC, so the automatic gain control, would not allow you to hear these smaller signals. It didn't have the dynamic range. It just didn't. These newer radios, the SDRs, primarily the SDRs, they have the narrow space dynamic range. So if you're hearing signals close by, that are stronger, you'll still be able to hear weak signals just fine. And, for the most part, you look at the top of this list. Yaesu FDDX101D SDR. Flex Radio 6700 SDR. ICOM R8600 SDR. Elecaf K3S, kind of an SDR, not really an SDR. It's more of a superhet / SDR. And you go down here, the ICOM 7851, that has DSP, it's not an SDR. And then you go down to Kenwood TS890, not an SDR. Hilberling PT8000A. Anybody spend $18,000 on this radio? You get good performance, but these cheaper radios are doing better. But you know what? Hilberling makes a nice radio. They make a very fine handcrafted radio. So if that's your thing and you like, a handcrafted analog radio, that is what the appeal is. I think he runs an aircraft avionics company, the owner, Mr. Hilberling, and he handcrafts these radios. You have Apache Anon. You go down here and so on. Perseus was one of the early SDRs, by the way. So basically the moral of the story is the top of this chart is dominated by SDRs. And it's just unreal what this has done to the performance metrics, and it's completely destroyed, the analog super heterodyne receiver designs. And the coolest thing about this is that once you want to get, if they make an improvement in the performance, all you have to do, you don't have to make a whole new radio. You could just update the software and you get those improvements. My radio has seen 3 version updates so far. 3 major version updates and a ton of minor version updates. The features have been continuously added. So, it's something to think about. The radio will essentially truly be future-proof in a lot of respects, right? So, by the way, speaking of dynamic range, anything above 80 to 90 dB third order is good enough. I mean, it's, your human ears are not going to be able to appreciate the difference between 90 and 116 dB. So don't let the numbers game be, discourage you. The ARRL lab, the lab, they do fantastic work. I think it's one of the best things that the ARRL does. The labs is there to review equipment and test equipment and tell members, show members that this is what on the market, this is how it's performance, no BS, unbiased reviews. Okay, and they came up with a metric called RMDR, reciprocal mixing dynamic range, which is essentially the same thing. So it basically tells you how your radio does in a crowded band. How they do this is they take some tones from a signal generator and they inject them at various intervals and they bring them closer until they notice the receiver starts to not perform as it should. There is a caveat. If you've ever had a situation, if you record audio, like me, I record audio, and you say you have your gain set too high, if you record an analog, it's not really going to sound too bad. I mean, you record that on a tape or you record that on some other analog medium. I think tape is really realistically the only thing that we have. it's going to sound a little distorted, but it's really not going to sound as bad as if you fire up Audacity, an audio recorder, and you clip, right? You'll basically, you know, it will sound really bad. So the same is true with RF. When you have signal overload in a SDR, there is really no wiggle room. Once you're at the top, you're at the top, because everything is digital. You know, you cannot go higher than the top end of the highest signal level in an analog to digital converter. There is really no wiggle room. So what a lot of these SDR manufacturers have been doing is that they put traditional analog filters in front, roofing filters in front of their analog to digital converters. And then they have that as an additional layer to basically filter out some of the stronger signals that they're going to see in the real world. So that's something to keep in mind. So let's talk about I say systems integration. I'm talking about station integration. That is the talk I'm going to be giving at QSO Today Ham Radio Expo in 2021. Eric Goose is going to have it in March, and Eric does a fantastic job. He also interviewed me on his QSO Today podcast. Really nice guy. He lives in Israel. 4Z1UG is his call, but he's originally from America. So this is my station in one iteration or the other. And you see my nice Centennial Challenge coins and Flex Radio, Elmer Award. So today, you know, your shack is built around computer, right? It's not really built around the, you know, just a radio and a pen and paper anymore, even though some people like that in their shack. And there's nothing wrong with that, you know, but the reality is most hams today are using computers. And a lot of that is blamed on digital modes, not just WSJT, but, you know, you have a lot of MCOM digital modes, you have WinLink, and you have other things that use computers. So computers are here to stay. Why integration matters. So you want to concentrate on the mission, right? Whether it is DXing, contesting, MCOM, you do not want to have to fiddle with a billion different things as you are doing what you're doing at the radio. You want everything to work, and preferably you have it where a lot of times these days people are having it where their computers are doing a lot of the work. So the other thing is too that these radio connections, the connections between the radio and the computer are pretty standard. Once you get one digital application working, you can easily get others working because the connection is standard. I talk about, you know, the full treatment to system integration, which I'll be doing at the QSO Today Ham Radio Expo in 2021. When that sign up comes out, be sure, don't miss it. Plus you'll have it on demand as well too. One thing integration enabled by new SDRs has enabled is less wiring. So because the path of signals is pretty much all digital, now they could have done this, by the way, they could do this in an analog radio. So just to be clear, they have a built-in USB sound card and such, and you know, but it costs them more to implement that. Whereas with an SDR, they can just tap off the digital sound and pipe that through a USB interface, and then you have basically USB sound card output. And you know, a lot of radios are coming standard with these. It's just easier to implement in an SDR. Then you have Ethernet. You know, I think this is the way to go. You have your radio on a network, you connect it to your Wi-Fi router, and then enables a world of possibilities. The biggest benefit, I think, for me, having a radio that does Ethernet, which is the Flex, is that I don't have a billion wires running all over my shack. I used to have a whole rat's nest of wires where You have one for the frequency readout from the radio, the CAT, they call it. Then you have one for sound. Then you have one for PTT. What a pain in the neck. Now I just have one Ethernet cable going to my Wi-Fi router. And then I have the computer also connected via Ethernet, and boom, I just set up everything in software. Let's talk about the exciting things, remote operation, when the world is your shack. So my life does not revolve around ham radio, okay, not a wrong typo. I have a family and other commitments, and I really don't like to, I love radio. It's just that, I don't spend all my time in the shack, to put it, nicely. But I still manage to work DX, and I still manage to use my radios. I can be all over the place, How can this be? Well, also it has good applications for EmComm. So typically you find the ham's paradox, as I like to call it. You have a good location for radios, but it's bad for operators, right? You usually have like a rural area away from, civilization, so to speak. I live in a rural area. There's nothing wrong with a rural area. It's just that a lot of people, they will have to either endure a long commute or they'll find some other way to make a living. So a lot of people are forced to live in cities. They're forced to live in HOAs. They're forced to, some people, they're older, they live in assisted living. Well, how can they still experience ham radio? They have remote operation. And I'm not really talking about where you could go on one of these services and pay money by the minute and operate a radio. I'm talking about where you have the radio either at a club station. This is becoming a popular option, by the way. There are a few clubs here that are setting up radios at club locations like EOCs and, other club locations, maybe a repeater site on the mountaintop if they have that, and they have an internet connection, and then their members have access to the radio. You can share radio. During Hurricane Maria, I lent out my Flex radio to a few people to help with aftermath. They remoted in. Somebody has a powerful station, why let them just basically hold that and, let it go to waste? You give the software to somebody else and let them log in and operate a shift, and that's a real good thing. So the internet becomes your studio transmitter link. I just thought I'd drop that in there in case there are any broadcasters in the house. This is where I am. I was in Buenos Aires, Argentina, and I pull out my iPad. I logged on when the Wi-Fi was working. The Wi-Fi was not reliable there in my apartment. And I remoted back to my radio at home. So it's a very powerful tool to keep you on the air when you're away from home. You can remote with a conventional analog radio, but like I said, you have to put a bunch of cables in it and buy an expensive box. Whereas with an SDR, it's easy. All of the audio and control signals are already digital. You can route that over the internet very easily, and you don't have to go and have a bunch of external hardware to get your radio remote. Let's talk about more tools of the trade. These are some things I picked up, and that is a Raspberry Pi, which I modified. And of course, now it doesn't have FCC certification because of that. But I'm a ham. I can use that for ham radio use on 2.4 gigahertz. But first, let's talk about what can you get for $1. You cannot get anything for $1 except maybe a smile when you give your waitress a tip. Or maybe she'll tell you that she needs more than $1. You can get a functional SDR receiver for $21. There is a software. There is a set of kits called SoftRock, and SoftRock basically, they are what I referred to earlier as the baseband SDRs. What they do is they have an analog converter that down converts the signals down to baseband range, and then feed it into a PC sound card, and you can then use the SDR software like HD SDR. They used to make a software called Rocky too, but you know, you can use that to listen. They make a transceiver. You can buy these for less than $100 at five-com. Excuse me, FIVE-.com. You can use them for monitoring, receiving. You can use them for CW skimmer. You know, you can even make QSOs on them using digital modes. RTL SDR, RTL SDR was a discovery made that some European TV tuners can actually operate as software-defined radios. So now there's a whole cottage industry around RTL SDR, and you find that a lot of people are now, excuse me, selling various solutions around RTL SDR. This is one called DX Patrol, but there are a lot of kits available, some of them from China, so they're very cheap, and then some of them, you know, from various European and North American sellers. This is more for DXers, so if you're in contesters, if you're in CW operators, are you getting out? Do you want to know how your station is performing, how far you're going? Well, you send a few CQs and go to reversebeacon.net and see how you're being heard and where. It's a good way to see how your station appears. You want to see if you're louder than somebody? Gee, I decided to put myself up against K1ZZ and K3 Whiskey Whiskey. If you go to reversebeacon.net/analysis, this works well if you operated a CW contest. This uses a network of SDRs, of CW skimmers, which basically use SDRs, and they feed all this data in, and then they aggregate it and they tell you who was stronger when. So it's good to see how your system performs. Oops. Okay, yeah. So as I mentioned about Whisper. Whisper is a good tool to know how your location performs. This was, again, from the talk with K3LR. So this is useful for all kinds of operators. If you want to know how the propagation is at your location, you can attempt to decipher all the propagation, you know, charts and stuff like that. And well, ARRL doesn't make the propagation charts anymore, and try to figure it out. Or you could run Whisper. What Tim said he did was, at his station, he ran Whisper for a week before every contest. And this way he knows when the band opens and closes. So you can know when the band will open and when the band will close. And this is very useful to telling you how effectively you can communicate at different times of the day and what bands are most effective. I've tried it out and it worked very well. I use it for contesting, but I also use it to know when I could get on and have an effective QSO whenever I wanted to. FT8, you can kind of do the same for the FT8 if you use a site called pskreporter.info. If you leave your radio on receiving on FT8 all day, it uploads the receive stations to pskreporter.info. You can then go back to that site and then you type in your call sign and you can then see what you received. And it might surprise you. You might receive some signals that are very far off, and it tells you the time and everything. Okay, anyway. So we've come to the end. Like I said, I run a YouTube channel. I've been making videos about twice a week, and I talk about ham radio, and I have content for old and new hams alike. And like I said, learn about the coolest hobby in the world. I always like people to be excited about ham radio. You go to youtube.com/RiaJara. Of course, you're always free to contact me on social media. I'm on Twitter, Instagram, and Facebook. And finally, you can contact me at either ria@n2rj.com or n2rj@awrl.org. I'm good in QRZ, so feel free to reach out. And I think we've come to the end. And Dan, I must pass it back to you.
Well, shoot. Thanks, Ria, very much. Are there any questions out there?
I'm sure there is. There's chat.
Yeah, in chat there is. Barry, go ahead.
Oh, you have chat, Ria? You can read it?
Yeah, I think I see Alan. Hey, Alan, W2AEW. Yep. And he shows
right below that.
Yeah. Retired software engineer, Raspberry Pi. Okay.
He's looking for references, I think, for more information.
No, I think Alan posted links to a couple of his videos there. Alan runs a nice channel too. He does a lot of he's an engineer, Tektronix, and he does a lot of cool techie videos. So you can check him out, W2AEW on YouTube.
Okay. Thank you, Alan. I guess we'll go for hands, Jen.
I don't see any hands up. This is good. Or bad. I don't know.
Or bad.
Okay. No more questions. No hands up. We have 121 folks out there. You must have done something right there, Ria.
Oh, I must have done something wrong. I must have confused everybody.
Oh, I don't think so. Besides that, they know where to contact you if they did.
Yeah, I answer a lot of email. I tell people, but don't feel shy. Contact me, and tell me, tell me, oh, my email box, I just got a flood of email, but not from you guys. But yeah, just ask me a question. I might even feature it on the channel. I take random questions from people and I just answer them.
She's busy
now. Does the IC7300 have a wideband output?
The answer is no, not stock. The good news is the IC7610 does.
Okay. Let's see.
What would you recommend to get your, okay, can you put my info? Okay, so I'll put my info in the chat, okay? But let me answer the question first. What would you recommend to get your feet wet in a low-end SDR? Good question. The low-end SDRs, I would recommend either, and I'll give you a few options. If you want a full-blown commercial transceiver, I would say the 7300 is fantastic for the value. Flex Radio also has the 6300, which you could get used. You could get the 6400, and then it gets more expensive there. But if you want something cheap to receive only to play around with, you get an RTL SDR, and you could find these all over the place. Now, the trick about the RTL SDR is designed for VHF, UHF, and you have an up converter that will convert the HF signals to VHF, UHF, and the RTL SDR in order for it to work. So that's in a nutshell. The soft rock kits are nice from 5dash.com. I built a ton of them. They're surface mount, but they have through hole components for like the resistors and capacitors. So they're really, they're really good. Let me put the info. So again, the YouTube channels at youtube.com/Ria Jaram. And then my email is ria@n2rj.com. Also on a blog at n2rj.com. And then you have my ARRL email, which is the same thing, is n2rj@arl2rs.org. Oh, losing it tonight. Right? And, feel free to reach out. Twitter, at Ria Jaram. Facebook, I'm redoing Facebook because I'm going to hit the 5,000 friends limit. So let me answer a few questions in the chat. Where is the IC7300? So the 7300 actually, I'll bring up the Rob Sherwood chart here. If Dan doesn't mind.
No, I don't mind.
Okay. Yeah. So the 7300 is an interesting beast because the 7300. All right. So here you see the chart. Maybe I'll make it a little bigger. Okay. You have all these at the top, right? All these SDRs are still going. There's the ICOM 7610, and there's the 7300. The third order dynamic range, I think that's it. No, it's wide space, right? I wish Rob would make this easier. Okay. 7300 B band pass. Dun, dun. Yeah, so this is, okay, there we go. So wide space 106. So this one's at a 97/84. I think that's with the, they have a, some sort of aliasing feature in the ADC that they turn on to get the 97. So let's say 97. A 97 is not bad. I mean, compare that to, you know, an old quote unquote high-end radio that they used to have. Like, gosh, you're going back here to like the ICOM 765, not 7, like the ICOM 7800. This was a $10,000 radio, okay? And look at where that is, 80, okay? So this thing is like blowing them straight out the water. An important consideration somebody asked in the chat is, they asked, is there an advantage to an analog radio for verse over an SDR? And the answer is yes. So some of these, and like I mentioned, the overload on the SDRs can be quite a problem if your radio does not have adequate front end filtering. I might have sent this privately to Bill. Oh gosh, I'm all thumbs tonight. Okay. There we go. Yeah. So the analog radios tend to be a little more tolerant of like strong signals close by. So example, you might find that in field day. And this is where the Elecraft, like the Elecraft K3 kind of stood out as a good field day radio because, and a good de-expedition radio because it was able to handle itself well in the strong signal environments, right? You'll find that like the 7300, you know, even if you had filters, it might overflow. Like you might see that little overflow indicator on, which indicates that it's starting to reach that high level where it's starting to go into clipping. So that is the advantage of using these, you know, the analog super heterodyne radios, right? Like I said, some of these radios have good front end filtering, so they will withstand. And a good practice for running multiple radios in close together is to have filters anyway. And filters don't have to be expensive boxes that you buy from a commercial manufacturer. You could basically get a T connector and build a coax stub. So you have a stub of coax that's tuned to notch out a particular, you know, set of frequencies, and you use that to basically manage your interstation interference. Speaking of which, there is a book all about this stuff called Managing Interstation Interference by W2VJN. I don't think it's in print. It might be, or it might be online somewhere. Alan might know. I think he's up on these things. So HackRF1, I want to get a HackRF1. Maybe somebody will bring me a HackRF1 for Christmas. Who knows?
Have you been a good girl?
I've been good. I've been good enough.
There's another question that you missed, Ria, and I'm not really sure it really is good. I mean, because the SDRs do not rely on having an internet connection, correct? They can operate off of the internet. correct?
Right. So, yeah, question. If you lose internet, do you have a workaround and dead in the water? So, so that was Jim's question. Okay, Jim, I'm sorry. I missed your question. So SDRs do not require internet except for remote operation. And some of them actually, now the Flex radios do require an internet connection initially when you first upgrade the software in the radio for the licensing, meaning that it'll phone home to verify the license for the software once, only once. And then you can take it and, you could carry it to the North Pole where you don't have internet, okay?
Okay.
And you're good.
Thank you.
Yeah. So, yep, yeah, and Alan posted the link to that the book, Managing Interstation Interference. It's a very good book. It teaches you all about, and it's not just for contesters. It's for people who, like I said, field day, or even if you're running emergency communications and you're running different bands at the same time. You want to filter out these stations so you can transmit at the same time, so you don't blow up your radio. Yeah.
Just so everybody knows. I'm sorry, Barry. I doubled with you.
Someone wanted to know what antennas you use, Rhea.
Yes. So my antennas, right now I took some of my antennas down. I used to have up a Stepper Monster. I took that down for repairs because it stopped working. There's a shock. The motors, one of the gears broke and it started to have high SWR. So I'm looking right now to either put up something else or fix the antenna and go up, and that's probably going to be a spring project. So this spring coming up, it's going to probably have something new up there, something used, or something else. I do have some backup antennas in the barn that I'm going to assemble and put up temporarily. We'll see how that works. Right. Also for HF on the low bands, I use a 4-square on 160 that I launch in the trees, believe it or not. And I want to do a video and presentation on that because I use some secret technology, so to speak. But it's really cool. I'm very loud on 160. And on 80, I use just a pair of 66-foot verticals. And those get out very nice. So I love the low bands.
How much property you have to work with those antennas?
Oh, just in New Jersey, I have a lot, but it's not as much as in Idaho. It's just 6 acres.
Okay. Well, not everybody in Idaho has a lot of land.
Well, no. The point is that 6 acres in New Jersey costs a lot more money than it would in Idaho.
This would be true. This would be true. Just so everybody knows, I will get, when I send out the follow-up email with the links to this video, I will also include the chat session so everybody get these notes.
Thank you very much, Dan. Dan, and let me say, just, on the record, off the record, I really appreciate this, that you bring the technical speakers together. So good stuff.
Well, appreciate
Tomorrow
that.
night, we're going to have an even better group. We're going to talk about the topic that everybody has been clamoring for. We're going to talk about HIPAA and how it affects emergency radio communications. So tune in tomorrow night.
I'm going to try. I have to see what I have on the tap tomorrow night. I might be able to, actually. Do I have anything?
Everybody else.
Yeah.
It should be a big showing. I'm expecting us to break the 500 tomorrow.
Yeah, I think I'll be able to make it, actually. The only thing I have is a YL net, and that ends at 9. So.
All right. I don't see any more questions out there. No hands raised, nothing in text. Looking at the crowd, you did a good job of not having that many questions.
Sometimes that's a bad thing because I like to keep people engaged. But anyway, so just to let you know, thank you everybody, and like myself, and also Alan posted a couple links to videos of his too. He does some good videos too, so you can check him out. And I'll see you guys around.
All right. Well, thank you very much. And if there's nothing else here from anybody, I'm going to close this out.
73 still up.
All right.
Thank you. Thank you. Thank you, Rhea.
Thank you.
Bye.
73 on 7VR clear.
All right, 73 is everybody. Please stay safe.
Thank you. Good night. 73.